The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation.
I'm going to do a quick, go. Justin, do you want to do an intro real quick, or? I'm infamous, for sure.
All right. Our keynote speaker is the czar. Can I call you czar of
Sure.
Critical Stack? Can we do that? Do you have a Lord Emperor? I don't know, Lord Commander thing?
Yeah.
Of Critical Stack, and once again, Liam Randall.
All right, well, BSides Cincinnati, thank you very much for having me keynote the conference this year. It's a tremendous honor. And it's sort of a different approach. I've spoken here before and at dozens of other conferences, and I'm usually known for giving these deep network security talks, try to do provocative things with network programming. But the keynote is an opportunity to sort of pull it back and think a little bit differently about what we're doing. So the theme that I wanted to approach today was disrupting security. So I'm going to talk about practical things that you can bring back to your organization to dramatically change how you're doing security and to hopefully take security up a bar. Before we get started, I want to point out that we've got a great community here around Cincinnati. Looking around, I see all the usual suspects, the guys that are at DFIR, the guys that are on the organizing committee, and there's lots of opportunities to get involved and take your career to the next level. Community is certainly at the heart of anything that we're going to do if we're talking about disrupting security. Today, throughout the conference, I would ask that you try to support all the speakers and do your best to tweet out anything interesting that they're talking about. Introduce yourself, give them a follow on Twitter, join the LinkedIn group, BSides Cincinnati, right now. While you're in there, just walk right down and send a LinkedIn request to the members in the group. Most of us are out here because we're incredibly passionate about what we're doing, and we love to find additional people to help out and work in security. So I'm not sure how many people are aware of the proud history that Cincinnati actually plays in network defense. There's more sensors run out of Cincinnati than out of any other place on the planet. And I mean Fort Meade, Fort Gordon, anywhere. Cincinnati has this great history of leading network security monitoring, developing new tactics, new techniques. And if you look at the companies that are out of Cincinnati, Critical Stack is mine. There's the Morphic guys, the CBTS guys, wonderful organizations such as Ashland, GE Aviation. There's a tremendous amount of talent here and around. And the one thing that I wanted to start out by pointing out is that Cincinnati taps all the things. I'll try to give you a little hint, maybe to get something started on Twitter. I'm really proud of what we're doing here, and I'm really proud when I think about the peers that we have here in Cincinnati. But let me introduce myself. This is me. So I'm a husband, a father. I'm presently the CEO of Critical Stack. I've been a serial entrepreneur for pretty much my entire career here. Skip around a bit. Minor technical difficulties. I'm really passionate about network security, and some of the things I've done in the past were I joined the Bro team at a very critical time. And one of the projects that I took on was actually rebranding the Bro. It was called Bro IDS at the time, as the Bro platform. Going out to the community, teaching a lot of classes, which I still do today. Was in Boston yesterday teaching a workshop on Bro. And even bought bro.org from a fraternity, which cost, I think, $10,000 to get that over. But I think that was absolutely worth it. I'm actually was educated here in Cincinnati. I not only got my CS degree at Xavier University, but I also was a network administrator there for 4 years. And after that, I've pretty much exclusively worked at startups. As was mentioned earlier, this is my current gig, Critical Stack. We're a pretty small team, but we've got some pretty big results. The biggest public product that we have is our probably Intel Marketplace. It lets you, dynamically build collections of security intel and stream it into your organization very easily. We've got over 5,000 customers at this point, and I'm very proud to announce that we were just acquired by Capital One Bank, which is an acquisition that I don't think anybody saw coming, us included, but we're really excited about what that's going to let us do as far as disrupting security goes over the next few years. You know, in joining all these startups, there's something about people that go into startups. There's a little bit of, you know, being exhilarated, you know, being excited, being a little bit crazy. Startups are a very hard place to go, but the one thing you all have in common is that you're hopeful. You're hopeful that you can actually change things for the better, that you can disrupt things. And when you look at the DNA behind startups, there's something that I think we can learn from and bring back to your organization, even if you're not in a startup today. People are motivated by all different kinds of reasons. When I look around now, I know that there are people in this room that are just really driven and excited about the technology. There are people that are really passionate and they feel like they want to change the world. There's some people that are just looking for the glory, and some people are just looking to get paid. And I've got a little bad news for that last crowd. You know, if you're out here because security's hot and security is a great way to make, you know, a fast buck, I don't think that you're going to be very successful. Now, that being said, you're here on Saturday, so I'm pretty confident that we're all kind of cut from the same cloth here. You know, that we're driven by something a little bit different beyond the typical reasons. You know, that we have that shared sort of passion. And if you don't have the passion for what you're working on, you're definitely not going to find success. Because passion is what drives you through the hardest moments, when things are really difficult. And to advance your career, you need to deliberately find where you're comfortable, you know, in the ocean and take a few steps out. Get out of your comfort zone. It's that passion is going to make you fight and elevate your career. There's a lot of folks here in Cincinnati that are doing world-class, amazing things. When I think about, you know, Coleman Kane and Mike Reeves and Brett Thorson and some of these other guys, you know, the thing that everybody has in common is that they're incredibly passionate about what they're doing. They wake up and they think about it. They come in on Saturday, they think about it. They plan it for weeks and weeks and weeks. Let me take you back a little bit. So 1995, I was a 17-year-old college freshman at Xavier. I had actually been hired by the university somewhat unexpectedly and worked 40 hours a week. And it was a crazy time for me, and I was just starting to experiment with a big network. I had 6,000 workstations to play with, and you know, I was responsible for deploying all the software across the university. And you know, we're experimenting with different ports and protocols. You know, you would kind of call what we were doing then DevOps today, but there just wasn't a name for it. Then it was just administrators, right? Every administrator, you know, knew how to script and knew how to do things. And I'll never really forget, is Gary here? Gary was my advisor at Xavier. And he's a great guy. He's still over there now. I'll never really forget the first exploit that I had the opportunity to work on at Xavier. And it was a really trivial one, but the exhilarating feeling that I got from working with that was amazing. And now that the statute of limitations is over, I'll tell you the story. So as an employee of the university, I did have responsibility for testing. You know, there was no pen testing category, and there was this new vulnerability that had been you know, circling around on Usenet and on some of the, you know, network, you know, early network security lists, and it was the ping of death. And like any, you know, young, inexperienced network administrator, I wanted to test it on my live production environment. And of course, when I pinged www.xu.edu, our brand new IBM Series 5 went down hard and did not come back up. IBM dispatched engineers, they replaced processors. It just kept getting worse and worse and worse. Finally, they just swapped out the whole box. You know, this was like our brand new toy in the information systems department. And I learned a lot from that. The first thing I learned is to keep my mouth shut, right? And that was some good advice from my advisor at the time. The second thing that I learned is that you know, you need to be more careful. And I went a lot longer from then till recently before I crashed another system accidentally without permission. But that wasn't really my fault. That was discovering a 0-day. The statute of limitations is not up on that one, so I have to wait a few years to hear about that one. What I really kind of learned and figured out about myself was what was really driving me forward. And you know, it's sort of become my personal mission statement. It's that I really like to work on hard problems that matter. You know, to find something that is important and very difficult, something that I almost feel is bigger than me. It's something that I can't wrap my brain around. You know, the water's a little bit deeper than I'm comfortable in standing in, and to get out there and to experience that. And when you're looking at the hard problems in security that are facing us, there's an incredible number of them. Security is full of hard problems that matter, but none more so than defense. Right? The defense of the network is a really intractable and hard problem, and that's what brings me to that. And that's the sort of perspective that I've had in my career, and that's what I'm going to talk about when we think about changing your organization for better. There's lots of ways to do that. I'm not dogging pen testers or red team, but frankly, if it were just taking down networks or breaking in, I would get bored because it's too easy. Right? A really, really hard problem that matters is trying to defend a network, because you don't have to be, you can be wrong once and you lose. On the other side of the table, you can be wrong 99.99% of the time and still win. Right? The odds just aren't in our favor when we're network defenders. Spending all this time in and around startups, you sort of figure out, what's the difference between the startup mentality, the startup outlook, and operating a business. Being inside an organization where you might be now. Maybe you are a student, or you work in information systems, or you've got responsibility for compliance, or you probably have responsibility for 50 things, too many things on your head. Startups have this luxury of sort of understanding that you're in a search for a repeatable, scalable business model, right? That everything that you think you know is just an assumption until you test it. When you turn over another rock, even if there's nothing under there, that's a win, because that's another technique that doesn't work. And good startups are pivoting and basically moving forward. And they align their development practices with those sorts of techniques. If you're familiar with like Agile, you do your daily scrum, and everybody comes in and you say, what'd you do the last 24 hours? Well, I failed on this, and this was a blocker. What are you going to do the next 24 hours? I'm going to try to do this, and here's the resources I need. And those opportunities, that's your collecting data. That's an opportunity for you to refine your strategy as you're moving through the pursuit to your goals. And organizations that adopt those very fast agile practices tend to succeed faster and better, because instead of batching up 200 changes into one big release and assuming, hey, we know what's going to happen here, let's put our change out there, our fix. That's a recipe for failure, because you're sort of putting 200 assumptions all together in there. And this is when you see organizations that are releasing 10, 12 times a day, adopting that kind of mentality on your security team is something that you can bring back to your organization. And those are the real two elements that I want to start with here. We have these hard problems that matter in security, and we also have this sort of startup mentality of the search for a repeatable, scalable process. How do we put those two things together in a way that can help you to dramatically change the security of your organization? So we're going to start by saying, why is security hard? Then we're going to take a look at the problem in its face, and we're going to look at some particular examples. Then we're going to get to what I think is the meat of the talk today. And that is really the disruptive strategy for security in your organization. And it's sort of a set of templates and a few techniques that you can use to manipulate your peers at work as a true social engineer to move your security organization forward. And then at the end, we'll take a quick peek at some NSM tools that you can use, if you're not using, you should be using, to try to drive your organization forward. And I'll give you some examples that you can bring back to your organization to try to help. So let's start with the sort of crux of the problem here. The crux of the problem in security is this time to exploitation. When you're looking at an attacker can take a new exploit, Heartbleed or bash bug, and within 24 to 48 hours have it weaponized and exploiting around your network. And if you compare that to this sort of traditional security process by which you have to identify, deploy, and secure new capabilities, it's a complete and total mismatch. It's a losing game. Because most organizations just aren't equipped to move quickly enough. And if you're following the move that Cincinnati has been a leader in moving into network security monitoring or NSM stacks, the idea behind those stacks is that collections of open source tools can be used to be customized very quickly to target emerging vulnerabilities such as Heartbleed and bash bug. But we still have this tension that defenders are fragile while attackers are very agile. Right? It's the difference between what they can do versus what we can do as network defenders. The second reason that defense is incredibly hard is the things that really matter in this country are capital assets. Right? Power stations, trains, buildings, aircraft carriers, automobiles, airplanes, construction equipment. These things take 5 years to dream up and design, 5 years to get funded, maybe 5 or 10 years to build. and they're typically outdated by the time they go into operations. And when you're running these and operating these capital assets, even if you had the ability to reboot the catapult on an aircraft carrier in the middle of the Mediterranean, you're not going to do it because there's an incredible operational security risk in doing that. And ultimately, there's this kind of good thing for us is that our jobs are going to be secure for a long time because it's going to take us decades to upgrade our way out of this capital assets problem. All of those risks are embedded in our infrastructure and are not going anywhere for decades. It's going to take that long to upgrade and update those sorts of solutions. But the most important reason that security is really hard is that we're falling further behind every day because we're on the wrong side of math. And when you think about the ratio of devices to people that are in your networks or that are under your responsibility, those devices are still growing at an exponential rate. Even just think of your house. 10 years ago, you might have had, maybe a home computer, maybe a laptop. And what do you have today? Maybe today, now you're married, so you've got your tablet, your work laptop, your phone, because you don't want to burn your data plan. You've got your Samsung TV, your Sony Blu-ray player. Maybe you put up a couple cameras to watch the kids in the backyard. You've got your security system that's online. I checked my house this morning before I came in, and I had 32 active devices in my house this morning. And I don't have like a big home lab. I'm not like cheating here. That's just, Internet of shit, kind of stuff, right? Some of it's very useful. Some of it's very creepy. And let's take a look at how creepy this problem can actually be. When people talk about, all these things that are growing, your cars are in the internet, trucking, shipping, lighting systems, it's embedded everywhere. And these are mostly capital assets. These things are getting released into production with no update or upgrade plan, little ability to manage them. When you think about them, compare, these internet things to, say, your computer. Right? With my computer, I have a chance, right? I can put a host-based agent on it. I can pull logs. I've got a bunch of arrows in my quiver here that I can use. I maybe have a user that could alert me that something's different. I might have network forensics because it's in a fixed place. But with these other types of devices, we're already handicapped from the start. We have responsibility for them, but do you have a HIDS for your phone that runs Linux? Right? Do you have a HIDS for your Teddy Ruxpin things that runs Linux? Do you have a HIDS for your car? Or is there an AV for your Samsung TV? Those are reasons why security continues to get harder every day. And to realize that, if you wake up tomorrow and you're still doing the same thing that you were doing today, you're further behind just by the nature of the problem that you're in. So the challenge that you have as security professionals becomes, how can I disrupt myself? How can I disrupt my security practices? How can I disrupt my organization's security practice to continue to refine and get better? It's that growing device management gap, being on that wrong side of math. So let's look at some of the things that I found on the internet, just quickly as a survey here. All right, so this is a light switch in Switzerland, sort of like home automation control panel. This is a grow lab in Kansas. I don't know what they're growing, but there's a grow lab in Kansas there. Right? I have no idea why that's on the internet. Here is like a Bloomberg type terminal in India. Okay? A power generator in France. Right? Why are these things on the internet? Convenience, always blending, that convenient versus security. There's going to have to be a lot of give and take between those two competing tensions, especially in security. Another home automation system in Spain. And if you look, you have access to the intrusion control system, to movies. You probably put Star Trek on TV or something like that. A developer working up at a university in New York, right? Wonder what license his code is under. Right? Probably free. A waste treatment plant, and that is literally poop on the internet. Right? These are for real. None of these are contrived. These are all actual things that are now connected. Whenever you find something that shouldn't be connected to the internet, just realize that if there's one, there's probably about 10,000 more that are also connected to the internet. And that goes for SCADA controllers, that goes for waste treatment plants, that goes for grow labs, that goes for anything. Here is a square image with quote that I didn't put the name on, and I don't know what that is. Oh, this is the worst one. This is a pig farm. right? And I've checked in on them a couple times. I don't know why, I just got emotionally attached to these guys. And it's partly because you can feed them, so I kind of feel like it's a little virtue pet. I'm not feeding them. I'm not clicking on the things, right? I learned my lesson the hard way. But the sad part is that you can watch the numbers go up and down, right? So this is bacon on the internet. internet over pork, right? All right, so this is probably combined with the Grow Lab. This is a planter, right? It's running seedlings into seedling trays. This is connected to real equipment. Somebody's on the machine, and some 12-year-old on the internet, some 17-year-old network administrator comes in and clicks this. You could take somebody's arm off. This is not a safe thing at all. A biogas plant, ethanol for the win, right? A Star Trek-themed home control panel. This guy's got his iPad, probably dressed as Captain Kirk, maybe a little Next Generation, he's got the works going on there. That's intense. A license plate scanner, and you can actually watch the licenses go by with tickets. Right, that's in Poland, but they have people have found them in the U.S. as well. A bus ticket dispenser up in, I think this one's in New York as well. Yes, RTC Transit. An AS400 terminal. Ouch. Somebody's walking through the admin section there when this got poked, right? This is the weirdest one. This is a cellularly connected Raspberry Pi mounted underneath a train inspecting train tracks. Why is this on the internet? I'm kind of glad it is. And I was curious. I was like, maybe this is like a model train or something. And I was like watching it. And I don't think that is, because that's some really fine detail on the gravel there. Oh, you guys didn't zoom in on the right spot. Here, let me see if I can do that. Wait, no? Oh, well, forget that. It zoomed in perfect right here for me. I could see it fine. Doesn't look good. All right, a bike rental up at, this is University of Stony Brook University. A fish tank skimmer. The scariest one I saw was an MRI machine at UCLA, right? A little DDoS on this, maybe it slows down. Instead of sending you radiation to your brain for 0.001 seconds, maybe you get it for 0.1 seconds. Not good. A city bus connected on cellular, and you can monitor the current state of the battery, that it has a self-regenerating charging battery there. And I called my kids over for this one. I was like, oh, kids, look, it's a bunny cam. It's not, it's a snake cam. That eats bunnies. I don't think my kids are going to forgive me. That's not going to happen there, right? Oh, bunny cam. Oh, it's so cute. Poor kids. A gas condensing boiler. A climate research station in Korea, South Korea, right? Oh, the worst Korea, right? A solar-powered P2P network relay, I think somewhere in Utah, right? Sitting out on a rock, just charging up their transmitting power. And then a good one here, a bad guy doing bad things, right? He's got a little rental box up at DigitalOcean and their New York data center. And he must not be very sophisticated because he actually VNC'd into the console and left VNC unlocked. And you see him here, he's like, looking at credit card numbers that he's, popping off somewhere. Not necessarily a good thing, right? So it's a huge problem, and the problem's getting worse, right? More of those things are going online every day, and many of them are with us for a long time as capital assets. So let's talk about security strategy. And this is where you, as a security professional, can go back to your organization and try to work more effectively. And I think that a lot of the big gains that you can get in your organization start with simply organizing better, organizing and executing better. When you think about how most organizations are set up, and in my career, I've had the great pleasure to work and consult to some of the leading organizations in the United States. In about 20 plus years I've been in technology, I've worked inside of hundreds of organizations, agencies, military, all around the world. I've had a lot of luck, and I've seen the same sort of fail patterns over and over again. And this is what I would kind of put the most common one. And I don't know where you are in this room. You know, you're passionate about security, so you're probably down in this area. You know, these people up here are less passionate about security. I would be kind of shocked if we had a bunch of people from there. And maybe you're even a vendor down in this area here. But the typical budgetary request cycle is that you know, you're putting together your wish list and you're sending it up, and they're rubber stamping no or yes on everything else, and then you take your budget and you get with vendors and you select it. And the problem with that is that you're not investing your entire organization into security. When you look at even my personal story, you know, Critical Stack, my company, was just acquired by a bank, right? There's this growing realization right now across all industries that if I don't own my technology, if I'm not the master of my own domain, so to say, that I'm going to be falling behind. That everybody's sort of realizing now, and it's the military, it's financials, it's industrials, that technology needs to be a core part of our business. And we're starting to see boards of directors prioritize and fund security initiatives, information system initiatives, because they see the big gains that can be achieved by organizations that can master those sorts of tools and techniques. And in that lies a tremendous opportunity for you to take a leadership role by teaching your organization how to implement security correctly. So let's put forward a basic security strategy. And this is very heavily influenced by the work of Richard Baitlick, if you're familiar with him, one of the absolute leaders. Buy all of his books, read his blog, follow him on Twitter, an absolute great guy, and one of the real fathers of network security monitoring. And I had the opportunity to work with a number of military organizations. And this was sort of the campaign model of security that we came up with. And the first step is to sort of recognize that in this modern security paradigm, people need to realize, and they are realizing even at the board level, that prevention is dead, right? And that this sort of new goal in security is not to prevent compromise, because it's not possible. It's certainly important to try to prevent compromise, but if you don't recognize that compromise is inevitable, you're already going to fail. So teaching your board of directors, say the one-level mission statement of our organization needs to become, we need to minimize the risk of loss to intrusion. Because right there, we're already recognizing at the top, at the funding level, at the prioritization level, that we're going to be compromised. And what that does then is that flows down through our security organization. That's going to change the metrics that you can use to present to your peers, or how you are evaluated for criteria of success or failure. And we'll move into that in just a moment. There's also this one weird trick. Let's see, Cincinnati father discovers this one weird trick to manipulate boards of directors. Click here to find out more, right? And this is the one weird trick that I'll give you that will make you taller, more happily married, more attractive, all the things. And that is to do this in such a way that they think that it is their idea. Lay the breadcrumbs to lead your bosses to this statement. Our goal is to minimize the risk of loss due to intrusion. Right? It's going to depend on people, but getting somebody that has funding authority to say that that is our new goal is the sort of key to unlock your success. Because you can bring that all of your requests back to them and say, hey, you set the strategy, right? You're the boss. You're telling me that my goal is to minimize the risk of loss due to intrusion. And let's look at how that'll flow down into your organization then. So the board and the CEO then are agreeing across these program goals. And we're going to say that our focus is to minimize the risk of loss due to intrusion. And as a CIO, you sort of get to set the high-level strategy for how that's going to happen. And you get to say that, hey, analytically, we're going to try to do rapid detection. Now, that's the one thing I want to report on. How quickly, what was the dwell time that organizations had, a threat actor had inside my environment? That should be in the heads-up report that's going to them. For every incident that we found, how long were they there? How quickly do we move from identifying a candidate incident to validating it as a true positive, false positive, or how quickly do we take a false negative, problem we didn't know we have, how quickly do we turn that into a true positive? How do we take those analytics and move towards response and containment? And that goal is aligned with this focus to minimize the risk of loss due to intrusion. And then with the CISO levels, you move down, and I know there's at least a couple CISOs here. You then become the campaign operator. You get to decide that, hey, we're going to match and hunt for particular intruders. I'm in healthcare, and these are the types of organizations that are attacking me right now. I'm in the DIB, the Defense Industrial Base, and APT-29 and APT-28 are my big threats. Okay, that's great. Well, let's start with the reports, and let's identify, here's the threat actors that we know are coming after us. Here's the tools that they're using. These tools have these capabilities. This tool does DNS-based exfiltration. Right? So the hunting and the matching becomes identifying their tools and then lining it up with a tool of your own that can detect that sort of behavior. Right? This is operating a campaign. So you lead your organization on hunting trips, if you will, out looking for these sorts of advanced threat actors. So then we get down to where I think I traditionally have worked a lot, and where I think most of us are in this room. Now as my security staff, I get to come up with the tools that I need to meet those leadership criteria that are in line with the strategies that have been set by my boss that all map to this ultimate organizational goal of minimizing the risk of loss due to intrusion. So down at my level, in the SOC, or the SIC, or the CERT, or the whatever you're going to call yourself, you get to now say, well, to match and hunt for those sorts of intruders, I need to collect this type of metadata. I need to collect all the PDFs, or I need to collect all the DNS. And you can now justify those requests on up through the food chain in order to escalate and resolve incidents. And finally, then, if you're a vendor, you now have an appropriate place in the organization as lining yourself up to what can I hunt and match for in my org. So questions? No? All right. So let's talk about some of the tools that we can use and how we would sort of line these tools up to different classes of metadata. I could probably not go an entire talk. I think I probably only said bro 2 or 3 times. I think my average per talk is probably about 40 or 50. So we'll be under my average, but we'll still go there. And let's take a look at the different types of metadata that we're going to be collecting here. When you're thinking about your network, you're going to be monitoring, collecting all different types of metadata. And these metadata has different properties, and it's from different tools. So think at the bottom level. You have full PCAP. So these are the full flows, symmetrical, so you have both sides of a conversation. And you'll always want to be collecting that, because there are a lot of incidents that you can only resolve through a pivot down to full PCAP. As we move up based on size, there are certain files that you probably want to be collecting, whether you're just extracting the executables or the PDFs and Excel Office files that come in via email, or perhaps it's backup files or PowerShell scripts. Those are things that you're going to want to collect. Protocol logs. So think like Bro output. And I brought a bunch of Bro cheat sheets. I'll pass these out after my talk if people would like them. These are just laminated copies of the default Bro protocol logs. Derived metadata logs, where you're taking this data here and you're performing an analysis on it, and you're making new metadata out of your original data, right? So think about, say, extracting every time you have a TLS handshake. The partners, the server will hand down X509 certificates, and the client will pass up a list of ciphers that I support and an order that they're supported in. And when you have anything, dumping you a list like that, it becomes a very handy little fingerprint. Maybe you want to collect over time and model what are the cipher fingerprints that we see in our organization. It's very easy. I've done this in organizations, and you'll see, things that you map to Firefox, things that you map to IE, things that you map to Chrome, and then you see a TLS handshake. So it's TLS on 443. It's open on the firewall. I'm not intercepting it. The certs may not tell you anything. Maybe it's a self-signed cert, but you can see that it has like a single cipher that's supported in there. Those are great little places that you can derive metadata to support your analysis in your organizational goals. And then finally, there's alerts. This 0.001%. I saw something bad. This person connected to a Zeus tracker. Is that a true positive or a false positive, right? Let's pivot down to our protocol logs and answer that question. Maybe we can tell, maybe we can't. Maybe we need to then go to full PCAP, extract files, and move from there. So when we're thinking about driving our way through that metadata, there's some properties of that metadata that just at a high level. With the tools, there's lots of different tools for collecting PCAP. NetsNFNG is a very popular one. That's the one that's built into Security Onion if you're not using that. There's a new one from Google that's amazing called Stenographer that is designed to work with the new AF packet interface in the kernel. So it's working on commodity Intel X540 10 gig cards. It actually will index the PCAPs as you go along. That works out to be 100% of your data. And when you're looking at what I'm collecting, you're going to be collecting like 110% of the data that's available in your environment. Because you're going to collect full PCAP, and then you're going to collect protocol logs, and then derived metadata, possibly files. So you're collecting the data in multiple times. When you're thinking about extracting files, this could end up being 5% of the data that's transferred. Maybe it's only 1%. It depends on your environment. But it's simple to use Bro as a primary extraction point, and then to use Zip, Mal Office Doc Scanner, a variety of other tools to then do further extractions from there. And as far as retention periods go with full PCAP, most organizations are just going to keep a couple weeks worth of full PCAP. Maybe you're a place like LLBNL, Lawrence Livermore Berkeley National Lab, whatever, and they actually use flow cutoff to keep a longer period of PCAP, but it's all truncated. So they'll keep, for example, the first 5 meg of every SSL or TLS connection, because the interesting metadata for them is those certificates and those handshakes that happen at the beginning. Once they've moved into the encrypted communications, it's less interesting for them. And they've actually been able to play that to their advantage. If you remember when Heartbleed broke, I'll actually pull this up here and I'll Google an article. So this could either be a great thing or a disaster. Let's see. Let's see here. So when Heartbleed broke, everybody who was out monitoring their networks had a problem. And that was that nobody's protocol analyzers really gave a crap about that heartbeat event, right? That vulnerability worked like this. Hey, Jason, ping, give me the 3 letters cat, and you send back cat. Hey, Jason, give me the 3,000 letters cat. CAT, bleh, throw me 2,997 bytes out of your memory. Right? That was how that vulnerability worked. And the problem was that everybody that was already running that NSM type stack, they're collecting they got full PCAP, they've got their protocol logs, they're pulling files out. No one could look at their logs and say, was I compromised by this or not? Because nobody's protocol analyzers, not Bros, not some of the commercial ones, not Suricata, not Snort, gave a crap about that heartbeat event until it was important. And in that case, when the support was added in Bro, Ashish and the guys out there pivoted back through their 2 years of network traffic captures. And I didn't like that the person that wrote this article didn't ask the interesting question of, you have 2 years of full PCAP on a 40 gig connection, WTF, how's that possible? And the answer is it's not possible. So this article is kind of wrong. They weren't able to pivot back through 2 years. What the article should say is, within the first 5 megabytes of SSL TLS sessions, we did not see heartbleed in any of those handshakes. Right? A little bit more accurate, but the point sort of holds here. When you're setting up these retention policies for your different data, there are a lot of times when you can only answer a question back to a certain point of time because you would need to go to full PCAP in order to conduct that analysis. Other types of metadata, derived metadata, keep that forever. These protocol logs, Bro logs or otherwise. Suricata seems to be moving a little bit in the protocol metadata logging direction. When you look at, they're now creating like an http.log and things like that. It's a great team over at OISF. Victor's doing a phenomenal job. Derived metadata, it's very small. It can be very small. Keep that forever. It compresses down very well. With things like Bro, for example, you'll want to have a strategy and say like, I want to have the last month of logs searchable quickly. So I'll set up an ELK database and index all those logs. But for long-term storage, that's not sustainable. So in the long term, we'll also put all of our logs into Hadoop. So we would have a long-term store where we can ask a long-term question, but still have the logs indexed locally to support the hunting use case of quickly pivoting through network traffic. And then when you think about alerts, whether they're from Bro, Snorri, Shirikata, or some other appliance, those should also be kept forever as well. So we've kind of gone through a lot of theory, and I like to do practical things. So let's pivot out and let's do a quick demo. Let's go ahead and, let me skip out here. All right. So I'm going to actually merge my screens together here. All right, so everybody see? Perfect. And put my baby in a pot. All right, so what I've done here is I wanted to start by looking at some of the different types of metadata to support these examples. And just imagine that we're actually looking at a traffic sample from poop over internet or bacon over internet or any other use case of thing. One of the reasons why I think many of us in this room here have gravitated to network security monitoring, NSM, is that the practical position that it gives us is that it allows us to monitor and intercept and to understand devices that are even outside of our control. If you're, there's nothing worse in any job as having responsibility for something but no authority to execute on those results. That is a recipe for disaster. If you're in a position like that, it's not going to end well. Right? You can't be held responsible when you're not allowed to make any decisions. Those sort of two things should go hand in hand. But with network security monitoring, you sort of put yourself in a position to be able to pull metadata from anything that's in your domain. And things like Bro are actually sort of attacking the network at the weakest point. The internet works because we've agreed upon communication protocols. And it doesn't matter if it's my phone, this remote control, that projector, MacBooks, Windows, Linux, we've all agreed upon those communication protocols. So if you're speaking SIP, I don't need an agent on that device. I just need an analyzer that can parse SIP, right? And I can now collect metadata. So what I've started with here is one of these Sans Holiday PCAPs. So who plays with these? Anybody? Couple? Okay, well, this will be new for most of you then. These are amazing. Ed Sudoukis does a great job. Every year he comes up with these really elaborate fictional scenarios, and he drops a PCAP to sort of highlight some of the year's most exciting attacks. And in this case, this is from 2011, so it's a little dated, and the victor, there was a couple laptops were being given away to the best, the winners of this competition. And so what I've done here is I've configured Bro to do a couple things for me. The first thing we're doing is we're simply just collecting protocol logs here. And who's looked at Bro logs before? All right. Bro's awesome. You guys, we got to do a workshop. Maybe we'll do that at the end of the day if everybody's still sober enough, which I doubt, right? Bro logs are basically collecting layers of metadata for you. So I like to think of it like Bro cake, right? So you think about in a network traffic, I might say, hey, JLo, SYN, and you'd say, SYNAC, right? So boom, we've got a TCP connection up right here. This is that flow layer, this crispy connection layer crust, okay? And this could be, UDP or ICMP as well, and Bro uses the mock flow standard, just like every other tool out there. And then on top of this, Jason, what protocol are we going to speak? We're going to speak TCP, and then on top of TCP, let's say I want to get a web page, so we're going to speak HTTP. So there's our next layer of our yummy Bro cake, right? We've got this creamy HTTP filling. And there's various types of metadata that are interesting from the connection crust layer about TCP. There's various types of metadata that are only relevant inside the HTTP layer. And I might say, get me a PHP file or a GIF or something, right? So we have a files layer too. So that's our whipped cream that's sitting on top of our creamy, cherry filling here and our crispy graham crapper, internet of poop again, cracker of Bro crust. And then on top of that, maybe you handed me a virus. So we could have an alert, and that could be the little cherry on top here. So when you're looking at these logs here, and I'll pass these out afterwards, think of them as layers of metadata. Let's just kind of do some OODA here. Let's orient ourselves with this PCAP and kind of understand what happens here. And we'll do that by pivoting through the layers of cake here. So let's start with con.log. And the Bro logs all have this nice little pattern to them. And as you start using Bro logs, or if you're designing or building your own custom Bro logs, you will learn this pattern and you'll master it very quickly here. So we've got the timestamp, a connection ID, which if there's any database folks in here, the connection ID is sort of like a primary key, right? You can use that to pivot between a slice of cake, for one flow, show me all of the con, HTTP files, notice, and other logs that are associated with that, all be linked by that one connection ID. So we see here that we had these two hosts, an originator and a responder, speaking on 25, speaking SMTP. And I'll just walk up that one little area there. So for the SMTP layer, or for the con layer, we collected things like duration, direction, size of the flow from the perspective of TCP. In SMTP.log, we have the same connection ID here. Some of this information has been selectively repeated here. If this were a real, normalized database, you wouldn't replicate it like that. But these logs are not designed for computers. They're designed for analysts to be able to quickly pivot into and not have to do like a join in my head. I just want to be able to see, oh, is this the host that I'm looking at here? Okay? And we see that we're collecting certain data from, who was the sender, the receiver, the dates, the self-reported user agents, mail title, and also there any unique files. So that connection transmitted 2 files there. So let's walk up to the next layer, files.log. And we see here that we have transmitting host SA and receiving host SA. We have connections that those were associated with. So in this first log, we have the same connection ID twice because we had 2 files. Right? And then there's certain metadata that we would extract that we're interested in for that layer. So things like file hashes, that they were extracted, what the extraction name was, and so forth. Right? And so what I've done here is I've customized a bro script to do dynamic MIME detection on every file and every protocol. And this is a very short bro script. It's up on my GitHub. And I named the file with the number for the order that it was in, put a dash, the protocol it was from, the file ID, and then I do a lookup to a table so I can name it with the correct extension. So here I have .text and .doc, which is helpful for this demo, which is where we're going to sort of quickly solve a problem using these tools, collecting these various layers of metadata. And so what I've done is I've extracted all these files, and now in Mac Preview, which I'm not recommending as an incident response tool, it's great for a demonstration tool, we can quickly understand what happened here. I'm an analyst. I just got a notice that there is a candidate incident. Now I have to validate, is this a true positive or a false positive? And in this process, we might even discover some things that we didn't get an alert on, some false negatives, and then I got to think, how can I turn those false negatives into a true positive? And remember back to our strategy. What the CEO and what the CISO should be collecting is if you're that person, you want to start tracking how long does it take to handle each incident, to do my quick validation steps for each incident. Because if you want to respond faster, which you have to do based on the math, those are the kind of metrics that you need to be paying attention to. It becomes like playing baseball. All right, so there was an email. And there was a Word document attached. And the browser went to this web page, Cincinnati list here. And I'll pivot back to the logs here for a second too. http.log. We see a get. All right, and we're going to look for favicon.ico twice, it looks like. No favicon.ico. No favicon.ico. I don't know why they asked twice. Ed made a wee mistake there. And somebody put name equals grandma into that box. Who knows HTTP? What's happening here? Filled out the form, right? They filled out that web form there. We go back to this web form, and when you see these web forms, these are typically launched as post requests. And from a technical perspective, I'm the web browser, Jason, you're the server. I write my data on here, and I throw it to you. Awesome. And then you process that data, and then you send me back my web page. A response. I think that was the favicon not found. Server error. Right. All right. So name equals grandma, and the web page that you sent me back was grandma is naughty, right? And this fictional scenario is, Rudolph got murdered, and we need to find out, did he do it? All right. And then we go cousin plus Mel is put that in the box, and we hit submit, and again that's a post request, right? Oh, there's the post request, right? And just thinking through it, so on this log, think of these like an Excel spreadsheet. There's 2 files associated with the post request, right? The file from the originator, which was a text plain, and then JSON sent me back a web page, right? That makes sense. It'd be weird if my server stopped delivering web pages, but we'll go on. Okay? So again, I'm being judged and evaluated by how quickly I can solve these problems. Then grandma puts %27 into the box and press submit. What's that? What's that character? Just shout something out. Oh, you guys can't see it? It's right there, %27. It is a single quote. Right, right. And what does that mean? It means grandma is a bitch, right? Because Jason just told me, you have an error in your SQL syntax. Check the manual that corresponds to your MySQL Server version for the right syntax to use near the quotes. And now, remember, I'm passive here. I'm just in the middle. I don't have access to Jason's configuration. I didn't know that he was running MySQL, but I do now. So as an incident responder, I've just collected some very powerful and important metadata. I could see, you know, in the traffic what he's saying he's running. Is he running Nginx? Is he running Apache? But he wasn't telling me that he's running MySQL to now. So both me and the threat actor just acknowledged that. And now, if this were my incident, I would mark this as confirmed, and I would pass this along down to somebody to remediate. Right? I wouldn't need to go. I might go further, but I would say this is, you know, now someone else's problem. But let's go on. So then grandma puts %27 show databases in. And the web server tells me information schema, my DNS, MySQL, and naughty list. And then name equals %27 show tables from my DNS. There's two tables, resource records and start of authority. This is a DNS server backend that stores its configuration of MySQL. And then grandma is really a bitch, show columns from my DNS, resource records. She gets the schema of the table, show columns from my DNS, start of authority, select star from my DNS. What are you authoritative for? You're authoritative for the North Pole. Nuh-uh, insert into my DNS.soa, origin.nameserver.mailbox.values for apple.com to nameserver1.santaslist.northpole. Status success, select star from my DNS. And now suddenly this DNS server is also going to respond for apple.com, except I'm sure she's going to point it someplace else. And this is there's a lot more fun to be had in this PCAP, so I'm going to bail out of this right now. But what I hope I've done today is I hope that I've tried to live up to what needs to be done in a keynote and really try to set those high ideals for what we can do, for what we should do, what we need to do. So I'm Liam Randall, and we've got a lot of great speakers today. I sincerely appreciate all of your time and attention, and I'll be around throughout this afternoon if people have follow-up questions or would like to discuss anything that I've talked about in more detail. Okay? Thank you. I think we're going to have about an 8 or 10 minute break or so before the next speaker. So if you guys want to take a human resources break, that would be wonderful.